Scientists may have just figured out how to roll back climate change. The only catch? It could cost as much as $5 trillion and use more steel than the United States produces in a year. Hey there, freezing fans. Jules here for DNews. Climate change is very real, and one of its biggest victims is Arctic sea ice. Since the 1980s, the amount of ice has, on average, dropped by more than 13% each decade. But fear not, because according to a paper just published in the journal Earth's Future, scientists may have an ingenious solution. It involves 10 million pumps. The plan is to refreeze 10% of the Arctic ice cap by using giant wind-powered pumps to cover the existing caps with salty seawater. When the seawater is sprayed on top of frozen ice and surrounded by the negative 40 degrees Celsius air, it freezes into new ice. According to the paper, it would take 10 million wind-powered pumps, outputting roughly 16.5 pounds of water per second, to add 3 feet of ice over 10% of the Arctic Ocean. For every 4 feet of water pumped onto the surface, the ice will become roughly 3 feet thicker, a plan that, if it works, will postpone the loss of the ice caps by about 17 years for every year they do this. As the researchers say, quote, implementation over the entire Arctic in the early 2030s would reset the clock to the present day. That's great news, because at the current rate, scientists estimate that the polar ice caps will be entirely gone by 2030. Of course, the plan isn't easy or economical. Each wind turbine used to power the pump will need to be roughly 19 feet across and use roughly 22,000 pounds of steel. The paper also states that 10 million pumps would only really cover 10% of the Arctic Ocean's roughly 4 million square mile size. To cover the entire area would take 100 million pumps and roughly 100 million tons of steel each year. The US alone currently produces around 80 to 90 million tons of steel a year, and covering just 10% of the Arctic ice would use around 13% of the US's steel production. The total cost would be $50 billion a year, or $500 billion over 10 years, and again, that's only if you cover 10% of the Arctic. To cover the whole thing would be a whopping $5 trillion. But not all efforts to save the Arctic ice caps are so costly. Another leading solution is called solar radiation management, where sunlight is reflected away from the ice instead of being absorbed by it, which leads to slower melting. One method of doing this is to inject reflective aerosol particles, particularly chemicals like sulfates, into the stratosphere. In nature, volcanic eruptions scatter sulfate particles high into the air as part of an ash cloud, and it's been observed that these particles reflect solar radiation back into space and lead to cooling of the Earth below it. So if we could do this artificially, it could have the same effect. In fact, a 2008 study found that if we could decrease the sunlight reaching the Arctic area by about 21%, it would allow the ice to remain even if the amount of CO2 in the air doubled. But this solution leads to many other environmental concerns, such as degradation of the ozone, which sulfates are known to do. It could also lead to a warming of the stratosphere, as the reflective particles would absorb some of the heat and disperse it into the surrounding atmospheric air. Both of these could ultimately lead to a worsening of climate change conditions. And the aerosol in itself is air pollution, of the kind that leads to asthma and other health problems. Ultimately, there is no simple, elegant solution. The paper itself admits that technology alone won't solve our problems. The world is still warming, the ice caps are melting, and sea levels are rising. Without the ice caps reflecting light away from the Earth, the ocean will absorb even more solar radiation and heat, which can influence global warming. Worse yet, the more ice is melted in the Arctic, the more methane, a greenhouse gas, will be released into the atmosphere. Currently, that methane is trapped under the permafrost, but as it thaws, it could speed up the effects of global warming. While setting up 100 million pumps or shooting sulfates into the sky might sound crazy, it might not be as crazy as the alternative.